Good. Recording started. So welcome again. And let me just explain to you very briefly in a couple of minutes what is the subject of today's lecture. First of all, there is an introduction. I want to clarify already today how the course is structured, how the lectures will be delivered, how the exam will be carried out, anything related to the subject, in order to clarify to all of you everything is needed to attend the course, take the exam with the full satisfaction by the students, by you. This explanation is recorded and will be made available in my YouTube channel, as I'll tell you later. So anytime that you need to get some refreshment about how the course will take place, you can go back to the video. And if you get also requests for clarification by your colleagues, other students who are subscribed but not attending today, you can tell them that the video is comprehensive. I will try to explain everything is needed. This will take about 1 hour today. 1 hour means from now to about 2:15 p.m. And then after this initial explanation, we will make a break. When I teach online, usually I make a break of 15 minutes every hour. I avoid to make long lectures without any break online because obvious reasons, because it is tiring, you know, attending online, it's a bit tiring. So I will make the break, and from about 2:30 today, I will start lecturing with a general introduction on the topic of climate change, a general introduction on what we are talking about. Some of you may find this introduction a little bit naive, a little bit trivial, but I think given that your background is very different, given that students from different schools, different faculties are attending here, I think it's important that we set a baseline, like a starting point that puts your different backgrounds on the same levels. We also have some PhD students attending this course, so I think it is extremely important that we, as I said, we fix a baseline. And I think that the diversity of the audience is an added value for you and also for me, of course. And because I think that, you know, climate change is an interdisciplinary subject. So I think dealing with climate change benefits a lot from the confrontation of different interpretation, different cultures, different backgrounds. So I think this is indeed one distinguished feature of this course. So first of all, what is the calendar of the lectures? And you find the calendar of the lectures online. I think you already know where to find it, but in any case, just to refresh our minds, I am opening web page, the web page of the timetable of the course, and just 1 second, and then I'm opening it, and then I'll share the screen. So let me just open it. Here it is. Okay, and just 1 second, because I need to include also students here. Okay, here is the timetable, and let me just share it. Share the screen 1 second. Okay, here we are. Okay, you should see my screen now. And this is the timetable. It's the version in Italian. Oh, no, it's in English, actually. It's the version in English. Okay, of course, it is written mixed English and Italian. No, this is the Italian version. Let me turn into English. Okay, here it is. So still there is some Italian. You have to be patient, but we can translate, and for any clarification, you can refer to me, as I'll tell you later. So today is February 17, 2025. And you see that we were planned to have lectures in room 4.2 of the so-called historical building of the Faculty of Engineering. This is the room for the first half of the course, the room that is reserved for us. However, some lectures will be delivered online. I'll tell you later. And then you see that we are expected to meet every Monday for 3 hours. When we meet in physical presence, usually I teach, I start at 1:15. I say again, when we meet in physical presence, usually I start at 1:15 because I adopt the academic quarter, so 15 minutes of delay. And then I teach for 2 hours of 45 minutes. So I teach actually 1 hour and a half from 1:15 to 2:45. And then I make a 15 minutes break in physical presence again, up to 3 p.m. And then I teach the last hour from 3 p.m. 3:45. So once again, the lecture time starts at 1:15 when we meet in physical presence and ends at 3:45. If you need any clarification while I'm talking now, please jump in and use, please, the micro, because I don't look at the chat continuously when I teach online, okay? I look at the chat once in a while. So if you need an immediate clarification, please step in with the micro. It's also very good that we have some interaction. So we have the lectures every Monday up to April 14, okay? And this is my part, the part that I am teaching, which is half of the total amount of lecture hours, 24. The total amount of lecture hours is 48. I am teaching the first half, 24 hours. And then my colleague, as you see from the timetable, Alessio Domeneghetti, will step in starting from Monday, April 28. And he will teach with a different timing. Please be careful, but in any case, we will remind you. So he's teaching on Monday and Wednesday, and the rooms are those reported here, okay? He will teach up to May 21st, and then Mattia Neri will step in, another colleague of mine, and he will teach from May 26 to June 11. Again, the timing is the same as Alessio Domeneghetti. It's reported here. Okay, this is the official timing. Of course, we may have the need to introduce some changes during this month, and any change will be communicated to you timely. What is the way we used to communicate with you? It's the forum of Virtuale. I will tell you in a moment where it is. The same that I used today for sending you the reminder that the lecture was online and not in physical presence. There is one important thing more that I have to tell you about this calendar. Even if we have rooms for the lectures, which means that if we want, we may deliver all the lectures in physical presence. Actually, this course adopts an experimental way of teaching, which means that we are allowed to teach 1/3 of the lectures online. And we will take advantage from this opportunity. And so some of these lectures will not be delivered in physical presence in the rooms that you see here, but some of them will be delivered online. I am discussing now with my colleagues in order to decide what lectures will be given online. We will let you know very soon. so that you can update your calendar. Actually, the fact that they are delivered online doesn't make a big difference, because also the lectures that will be delivered in physical presence will also be delivered in streaming online. So the moral of the story is all the lectures are available online. Some of them, and I will tell you what ones, will be delivered both online and in physical presence. So for these lectures, you have the opportunity to attend in physical presence if you wish. Okay, it's a way to give you an additional opportunity. In terms of my advice to you, given that the lectures in physical presence will be 2/3 of the total, my suggestion is to try to attend some of them indeed in physical presence if you can. Why? Because our experience suggests that the hybrid solution, which means mixed physical presence and online lectures, is successful if indeed there is a physical part of it. If you attend only online, you miss some important connection with the teacher. This is the advice that I give to you. Ideally, it would be nice that you are, so according to my advice, it would be nice if you indeed made an effort to attend in physical presence the lectures that are delivered in physical presence. It would be nice because, as you will see, it's important, the interaction between you students and the teacher. Also, this is a subject where interaction is extremely important. This is a subject that is not really complicated in theoretical terms. As you will see, it's very descriptive. It's not really complicated. But on the other hand, it's very diverse. And this diversity of perspective, of disciplines involved, you can perceive it, you can fully get it if you have an interaction with the teacher, because basing on the interaction with the teacher, also I will tune my lectures, and I may modify also the content of the lectures. So I think the interaction is indeed important. On the other hand, please be aware that in terms of passing the exam, it doesn't make any difference. It doesn't make any difference even if you didn't attend any of the lecture, both online and physical presence, because you will have the recording of the lectures. You may also decide, and some students already mailed me to let me know that they cannot attend. And I said, no problem, because I am recording the lectures. And therefore, you can attend asynchronously. So you can watch the recordings later on. And this is enough to pass your exam with full satisfaction for you. So actually, if you cannot attend in physical presence, even if you cannot attend at all, you don't have to be concerned, because in terms of passing the exam, I mean, the only thing that you miss is something that is not related to passing the exam. It's related to what really you get from this subject, and what really makes you an expert. Because, you know, to make you an expert of a topic is not enough to pass the exam. Passing the exam, of course, it's a requirement, and it's a requirement for getting your degree. But if you want to become an expert, if you want to spend your skill in the most profitable way, you have to get more. This applies to any subject. And in order to get this more, my advice is try to make an effort also to stimulate an interaction with me and with the other students. Okay, now let's go back to the logistic, okay? And here you see that then the timetable is here, and once again, I will update it. once I know what lectures will be given online. Of course, you need to know it, because if you go in physical presence, also here it will be modified. If you go in physical presence, when the lecture is delivered online only, of course, you don't find anybody, you don't find the teacher as well. So it's important that you know. We will update this timing once I discuss with my colleagues. And then let's see where you can find the teaching material, the lecture notes, the video, whatever, okay? So there are two places where you can find it. And one place is my website. So let's start from it, okay? This is my website. You see the address here, okay? It's just www.albertomontanari.it, okay? And so this is where you can find any information. Where exactly? If you look at my website, is broadly divided into two sections, teaching and research. Let's focus on teaching for now. And here you see lecture notes for science of climate change is the second. If you click here, you find here, first of all, the calendar of my part only, because this is a reference only for my part, okay? I'll tell you later where you can find the lecture notes for the second half of the course, the second half that will be delivered by my colleagues. So first, you find here the calendar, which we already have discussed. And then you can find here a lot of information that you may need, the same information that I'm sharing with you now. And so you see that here it's indicated basically the content of my part and tutorial documents. So the tutorials for my part will be delivered in the form of open web pages, open media, and they are freely accessible. Also, the videos will be freely accessible. What do I mean with freely? It means that my website is open to the world. It's not reserved to people attending the University of Bologna. It's open for everybody. And this is a choice that I made already 12 years ago when I decided to adopt the philosophy, let me call it this way, of open teaching, which means that I want that everything that I teach is available to everybody. So this means that this material will be accessible to you even later on when you are not a student anymore at the University of Bologna. The material will remain available. And this material is also updated. So you can take this website as a reference for this topic for you in the future. And as I said, the lectures are given in the form of web pages. I click on one, for instance, the Earth system. Let's click here. And you see that it's a web page reporting the content of the lecture. And why I use this format? Because first, it allows me to include links, which are extremely important in order to give you additional information. And second, it allows me to quickly update the web page, to quickly update the content, to quickly update correction, to make everything continuously updated. In some of the cases, you will find in the bottom of the lecture a link to a PowerPoint. Let's see if in this lecture it is there. Okay. So let's look at here. End of the lecture. You see here, download the PowerPoint presentation. The PowerPoint presentation is a cut and paste and a synthesis of what you find in the web page. So the PowerPoint, it is just useful to me to teach because, you know, I go to the initial part of this web page of this lecture. You know that if I started teaching by looking at this web page, it's not ideal. There is too much text. For teaching, I need something more condensed. So this is why I make the PowerPoint available. My suggestion for you, don't use the PowerPoint to get prepared for the exam, because you are missing a lot of information. And it is information that I may require at the exam. And the PowerPoint is maybe useful for studying, just to get a refreshment, a very quick refreshment. But on the other hand, as I said, if you just study on the PowerPoint, you run the risk of getting not prepared enough for passing the exam. So just take this opportunity to use at best the material that I make available. In these web pages, as I said, you will find several links. These links, in general, most of them refer to Wikipedia. So for instance, let me click on one link, holistic. Let me click on it. In this case, it's not a Wikipedia page, it's a page from the Cambridge Dictionary. So let's go back. Feedbacks, let's click on it. In this case, it's a Wikipedia page. So what is the purpose of the link? The purpose of the link is to give you additional information on some issues that I believe you may need some additional information. But if you know already the meaning of what a feedback is, you don't have to click on the link. It's not necessary. In particular, keep in mind that for passing the exam, so the questions that I may ask at the exam, they can be addressed, solved completely by just looking at the web pages. You don't need to follow the links to address the questions that I will ask you at the exam. Okay, so the links are additional information that, of course, it may be useful for you, especially if you are interested in the topic and you want to expand your preparation. So this is the meaning of these links, but once again, to prepare the exam, you don't need to follow them, okay? And I often make reference to passing the exam because, of course, passing the exam is important, but please be aware of the difference between passing the exam and becoming an expert on the topic. Becoming skilled. And the skills are very important, of course, but of course you cannot be an expert of every topic you study. But for those topics where you see your future, you see they are important for your CV, try once again to make more than what is required to pass the exam. I just wanted to make clear that, of course, I make reference to passing the exam. It is extremely important. You need it. On the other hand, just beware that becoming an expert is something more. Okay, so these are my tutorial documents. Now, let me go back to the main page. As I said, videos are made available, and they are made available in two locations. Let's look at the first one. The first one is YouTube. YouTube is open to the world. And of course, I wanted also to get a location that is open to the world. On the other hand, YouTube has an inconvenience, which is advertisements. So this is why I also wanted to put the videos in another location. YouTube, some time ago, didn't have the advertisement for those people that don't monetize from the clicks on the videos. And then they changed their policy. Of course, I'm not monetizing, but still I get the, and my students get the advertisements. So if you are annoyed, actually they are not very annoying, but if you are annoyed, there is another location which I'll show you later. So let's look at the link of YouTube, playlist of science of climate change 2025. If you click here, okay, let me accept everything. If you click here, you see that there is nothing, of course, because the first video will be made available like tomorrow, which is today's video. On the other hand, later on, you will find here all the sequence of videos for my lectures, okay? I mentioned another location, sorry. I mentioned another location. Okay, the other location is Virtuale, okay? And because I made a link also at this course, also on Virtuale. What is Virtuale? Virtuale is virtuale.unibo.it. I think it's already opened somewhere here. This is Virtuale. And you see that you have access to it if you are a student at the University of Bologna. Just 1 second, I take an opportunity to look at the chat because I want to make sure that, okay, nothing new, perfect. So this is Virtuale, and if you log in, of course, I log in with my credentials, so you don't see the same thing that I see. If you log in, you will find, today Virtuale is a bit slow, I don't understand why, but you will find in Virtuale link to Science of Climate Change. And here you see a link to the virtual room. And let's click on Science of Climate Change. And you see here a copy of my lectures. These are just copies from my website, okay? So what you find here is the same thing that you find on my website. Later on, my colleagues will put here their additional lectures, okay? Here you see also something that you don't see on your page because it's my account and therefore there are some past lectures that I removed, but they are still visible to me, but not visible to you. Okay, in Virtuale, here on the right, let me activate it. You find a link to Panopto, and Panopto is the repository of where the videos of the lectures will also be uploaded. So you will find here a link here on the right under Panopto to the videos of my lectures. These are just copies of the videos that you find on YouTube and just copies. The only difference is that you don't get advertisement. It's available for you only. But there is no additional information. As I said, they are just copies. They are recording taken from Teams. Okay, and in Virtuale, there is also a link to the news. So if you click here, you see that there is a forum and you see the message that I sent today, okay? Please make sure, this is the way I communicate with you. So when I have something to communicate, like cancellation of a lecture or whatever, I will use this forum or the chat in Teams. For important communications, I will use both. So make sure that you are subscribed on Virtuale as a participant to this course. Now there is a list of participants here, which is taken from your study plan. But if for some reason you are attending this course without having it in your study plan, you are not automatically subscribed to the course in Virtuale, and therefore you have to manually subscribe. You are allowed to do that, so you can manually subscribe to this course. Make sure you are subscribed, because besides accessing the material, it is important for the forum, for the communications. Keep in mind that what I published in the forum is sent by email to all the participants, and therefore you receive timely on your mailbox any communication that I deliver. So once again, be sure you are subscribed here. Okay, if you have any question or for some reason you can't subscribe, just let me know. Okay, so this is the situation for Virtuale. I think I don't have anything more to say. There is actually one important thing that I want to say. In Virtuale, there is only one thing that you find which is not available on my website, and it will be the self-evaluation test, because I make available on Virtuale a self-test to check your preparedness for taking the exam that will take place with a procedure that I will tell you in a moment. Self-assessment test. This is anonymous. Okay, it should be somewhere. Let me just go back to here to the web page. It should be somewhere here. Let me see. Maybe that it's still hidden. I'm not sure. Let me just see. This is no, it's here. Okay, self-evaluation. Yeah, it's hidden. For now, it's hidden. Oh no, it's here. It's available. I would say yes, it is available. So this self-assessment test, if you click here, should be available to you. And of course, it tells me that I'm not allowed to attend this questionnaire. And it's an anonymous questionnaire. Once again, completely anonymous. The test is, I think, very useful because it's a kind of a replicate of your exam. The only drawback that there is in this self-assessment test is that in order to make it anonymous, I had to accept that the feedback to students is delivered only in terms of statistics. So if there are, let's say, 20 questions, the result is reported to you in terms of number or percentage of questions that you made wrong. It doesn't tell you you were wrong here, here, and here, because this is a requirement of the software if I decide to make it anonymous. On the other hand, you can repeat it as many times as you want. And therefore, of course, with a trial and error procedure, at the end of the story, you converge. Okay. If in the future you have any doubt on this test, because sometimes the students don't understand what they are making wrong, just contact me. Okay. Okay, so I would say that for Virtuale, this is everything that you need to know. Okay. And then you can decide whether to refer to my course or Virtuale, the one that is most convenient to you, of course. Let me just close this window. I think we don't need it anymore. And let me come back here. And now let me talk about the exam. Any questions so far? Let me look at the chat. Okay, no questions. Exam. First thing, the exam cannot be taken before the end of the lectures. Or let me just say, cannot be recorded. So I cannot record a transcript before June 11, I think, before the last lecture. So we will make a schedule of the exams, of the calls. There will be 3 calls before end of July. Typically, the first call is around June 12. So 1 day later, the end of the lectures, because once again, we cannot record any transcript until the lectures, until the end of the lectures. And then we will make another call around June 25, 26, and then another, the third call in July, mid-July. There will be a 4th call in September, typically around September 12. There will be a 5th call in December, like beginning of December, and another call in January 2026. These are 6 calls for the exam. If you need additional calls, you can email me. Keep in mind that you should make an effort to stick on the scheduled dates. So I will tell you the schedule shortly. I need to take an agreement with my colleagues, and I need to take a reservation for the labs where we will make the exam. So I guess that around by the end of March, we will be able to give you the full schedule up to the end of the year and January 2026. Try to stick on these dates because for additional dates, it may be a bit complicated because we have to find a lab, many things, and it is absolutely not easy. So try to stick on the dates, and in case for major force you need additional dates, like because something went wrong or whatever, you can contact me, us, also my colleagues, and we will do our best. But please don't assume that you are granted additional dates on demand, because this is unfortunately not possible. I mean, we can check it, but it doesn't depend on us. Keep in mind that, of course, you may take an exam and decline the vote. It's not a problem. You can decline as many times as you want. We don't record any decline on your transcript. Of course, you have to wait for the next call. So it is not possible, as I said, to grant additional dates for sure. So full freedom of declining the votes, but on the other hand, try to make your plan in a reasonable way. For instance, if you need to take your degree, and you know that in order to get your degree, you need to have completed the exam by a given deadline, just make sure that with additional calls, you can meet the deadline, because it happened in some of the cases that the students declined the vote, and then they were not meeting the deadline, and we couldn't fix another date, which means that they had to postpone the degree date, and this is something inconvenient. So try to really make your plan in a wise way. Okay. The exam, I need to check with my colleagues, but I think I can confirm what you find here. So the exam is a quiz. It is online quiz, but please make sure you get this. It is to be taken in physical presence. We are absolutely not allowed to give the student the option to take the online quiz not in physical presence. So you have to come into a lab of the university, and you have to take the quiz from the lab of the university at the presence of the professors, for obvious reasons, because we are not an online university. So even if we have the opportunity of delivering some of the lectures online, even if we take advantage from online facilities, so we give the option to take the exam through a quiz, then on the other hand, we have we are obliged to take the exams in physical presence. Just make sure that you understand this, because sometimes, especially for the Erasmus students, this requires careful planning. Because if you have to go back in your country, if you are an Erasmus student, then it means that if you need to take an exam in physical presence, you have to travel back, and therefore you have to make a careful planning of your exam dates. The quiz is, as I said, online. It's have a duration of 30 minutes with 30 questions, and this timing is long enough. I tell you, statistically, it's already some years that we use after the pandemics. Many of the professors turned to this online option. And of course, I repeat, the questions in the quiz, they are closed answer questions without penalty, which means that you get a question, you have like 5 possible answers, and if you pick up the wrong one, you are not penalized, okay? And these questions are related to topics that are discussed during the lecture and you find in the lecture notes. There are no questions outside the domain of the lecture notes. On the other hand, keep in mind that you know, you need some preparation, of course. Given that there is no penalty, of course, if you are in doubt with some of the questions, just try. Don't leave questions unanswered. It's absolutely inefficient. Any correct question give to you 1 mark, and therefore 30 questions, the max mark that you can take is 30. Keep in mind that usually you don't need to answer correctly to all the questions to get a final mark of 30, because given that the questions are randomly chosen for each of the participants to the exam, you know, we also look at the random selections that each of you has got. And in some of the cases, we may decide that, you know, some errors may be justified by the fact that the question was particularly tough. And therefore, you don't have to be like concerned, I have to be 1%, 100% correct in all the questions. You are allowed some allowance, okay, for errors, for possible errors. Keep in mind that you can, during the exam, consult your lecture notes. You can also browse the web to look at my web pages. And so there is a lot of freedom in that exam. On the other hand, this is just my experience, usually the students who are happy with the outcome are those that didn't need to consult anything. And the reason is very simple, because consulting lectures, consulting web pages means time. So 30 minutes for 30 questions are a time span that is long enough if you are prepared. If you start looking at the web, you know better than me that easily browsing the web takes 3 minutes. And therefore, you understand that time may be not long enough. So my suggestion for you, you are allowed to consult notes, but try to avoid this. Try to make sure that you don't have the need to consult notes. So when you get your self-assessment test done, if you need to consult notes for making a self-assessment, it means that you are not prepared enough. Of course, you may decide that you don't want to get the max score, but if you decide that this subject is interesting for you, you want a good score, you want to become an expert, then if you need to consult the notes for making the exam, it means that you didn't get to target. Okay, so now you may ask me what you are not allowed to do during the exam. You cannot use artificial intelligence for creative purposes. So I think you know better than me what this means. And just keep in mind that there is an ethical code of the University of Bologna regulating the use of artificial intelligence recently adopted, which means that not using artificial intelligence for creative purposes is an ethical requirement now. And this means that if you fail in meeting the ethical requirements, you are sanctioned by the university. And my suggestion for you, try to avoid this, because it is really, we had some trouble. It is really embarrassing, and it's a real problem. If you infringe any ethical requirement, it may have implications on your degree CV. And I mean, just try to let's agree that you are not tempted during an exam to use artificial intelligence. And I also suggest you, I mean, try to be careful, especially when you prepare your master degree thesis, because we had some your degree thesis or your reports that you have to. In this case, you don't have anything to deliver to me for this subject, but for other subjects, you may be required to deliver reports. Just try to be very careful, because of course, artificial intelligence is an opportunity, but it's also something that is really complicated to understand, to use in a correct manner. And unfortunately, some students really had significant problems regarding the use of artificial intelligence and the web material in general. By the way, anything that you find on my website, as I said, is free, so you can reuse everything. And of course, if you cite it, I am happy, but you don't need my permission to reuse the material from my website. So I think that that's it, basically. Let me just think if I have something more to say. I just, yeah, there is one thing. There is one thing, the exams. In order to book your exam, you have to go to Alma Esami. You know what Alma Esami is the web platform of the University of Bologna, where you consult the calendar of the exams and where you can book for it. If for some reason you don't have access to Alma Esami, for instance, because I'm not sure if PhD students have access to it, if you don't have access, just contact me and let me know. And in some of the cases, the PhD students, for instance, don't need to take the exam. But if you need to take the exam, then we have to resolve on paper or on something in a different manner instead of using Alma Esami. Yeah, let me know if you have any questions, please. Let me check. Okay. And then let me go back to our list of lectures. And then after after the break, we can start. In order to, I take some more minutes from you in order to clarify, to say a few words on my profile, because I think it is an interesting information for you to know the profile of the teacher that is delivering the lectures. I am an engineer. This subject is open to also to students from other schools other than engineering, and this is very nice. My background is engineering, civil engineering in particular, and in particular, I am expert in hydrology, which is the science that studies the water cycle. So I am an expert of rainfall, of river flow, groundwater flow, water resources management, anything that is related to the water cycle from the point of view of engineering. And actually, as an engineer, I also made in the past some professional activity, but for starting from about 20 years ago, I decided to make only research and teaching as my subject work. Research and teaching in civil engineering teaching, and research in particular in hydrology. Hydrology also involves sister disciplines to some extent, like, for instance, economy, because of water resources management, or climate science. Actually, when I started making research on hydrology, and in particular on flood mitigation of flood risk, mitigation of drought risk, and water resources management, I realized, it was about 20 years ago, that it was necessary for me to get some preparation, some background on climate change, some knowledge of climate change, because already 20 years ago, climate change became a central issue in all the scientific disciplines and also technical disciplines dealing with climate. And you may feel that climate change is a recent concern. Actually, it started already 30 years ago. The first concerns in a modern sense about climate change, because climate change was also a concern of people in the past, in the far past also. But let's say that in the modern sense, which means global warming, actually, climate change became a concern for international society and international scientific associations about 30 years ago. And during these 30 years, actually, I didn't see an increase of popularity of the subject. It was already very popular 20 years ago. And so it is indeed something that is not new. On the other hand, the science made significant progresses during these years. And I realized already 20 years ago that a person dealing with the engineering of hydrology and the engineering of environmental conservations needed to be prepared about climate change, because climate change was really climbing up in the agenda of institutions, in the agenda of water boards, of boards managing irrigation, for instance, or drainage. And therefore, I decided to get some preparation, and I studied climate change. My study of climate change is focused on the engineering related to it. What I mean to say that I never had the ambition of getting prepared expert on climate science per se. So, for instance, mitigation of climate change, that is specifically a subject for climate science, has never been one of my primary interests. So I'm not an expert on decarbonization, on reduction of the emissions in general, because I thought that this was not really my issue, and I thought I was not prepared enough. Instead, I got very interested in adaptation to climate change, because I believe that a climate change adaptation, which means finding solutions to mitigate the risk associated to climate change, I thought it was, I still think it is typically a task for engineers. Actually, there are also many climate scientists dealing with climate change adaptation, but I think the contribution of engineering is fundamental. And as an engineer, I got the key role of uncertainty assessment, because of course engineers are well aware of the key role played by uncertainty, which is something that we can deal with. Engineers are used to deal with uncertainty, but of course we need an assessment, a quantification. And I got so very interested in climate change adaptation and climate change uncertainty, which are topics that in a way are a bit, I wouldn't say controversial, but let's say that there is a lot of discussion. And so when I will teach science of climate change, I will also teach something related to mitigation, decarbonization, but actually the central focus of this subject is is climate change adaptation, the science of climate change adaptation. Again, I will teach also something related to mitigation, but actually I'm not interested in the politics related to it. So I'm not interested specifically in international relationships because once again, I'm not saying they are not important. I mean, climate change mitigation is a topical issue, it's extremely important, but I feel that it's not something that is conform to the background of engineers. So I will focus more on adaptation and uncertainty. On the other hand, if you want, if you are interested in something more specifically related to mitigation, I don't see it as a problem. I attended as a supervisor several students who prepared bachelor and master degree thesis on international relationships, on the politics and the economy of climate change. So I'm really, motivated to learn. And of course, the kind of assistance that I can provide is different with respect to the kind of assistance that I can provide on climate change adaptation. Okay, so I propose at this stage I forgot to say, basically now, as I said, my main activity is research and teaching. So if you are interested in anything related to research on climate change, I am very willing to discuss with you and also to provide assistance if for any reason you need to get prepared on specific issues. And of course, I am more than willing to provide assistance on hydrology. Hydrology and climate change, hydrology and climate are strictly related. I am more than willing to support you if you need to, in a way, deepen your preparation on hydrology, climate, and climate change. So I think now we can make a break, 15 minutes, and we can meet again at 1:30. And during the break, just to let you know, I will turn off the micro and the webcam, but I will keep the meeting open and also the recording, because my experience is that if I make an effort to stop the recording during the break, then I run the risk of forgetting sometimes to stop, sometimes to restart. So I prefer to keep the video moving on, and which means that when you will rewatch the videos, you will have the 15 minutes break once in a while, and therefore just beware, you just have to skip them. Okay, if you don't have any additional question, let's take this break and let's meet again in 15 minutes. Thank you very much. So here we are. Do you have any question related to what I presented in the first hour? Okay, no questions. Please don't hesitate to ask questions. As I said, interaction is extremely important. Interaction online is not easy, I know. But on the other hand, I will make an effort to stimulate your reaction in because it is, I mean, the key step is to break the ice. And then I will try to stimulate you also to give ideas, to make comment, to be critical if needed. Because as I said, your background is very diverse and therefore diversified, and therefore, I mean, I think the interaction is really an added value. Okay, so what are we discussing together? We are discussing, and let me share the screen. We are discussing, as I said, science of climate change, and this is a brief list of what I will talk about in my part. So you see, climate history, advanced techniques for environmental monitoring, climate physics and modeling, modeling of climate-related processes like water cycle and natural hazards, and then solutions for climate change mitigation and adaptation, with a little bit of more focus on adaptation, and climate analysis with open data and open software. This is like a list of dreams, you know, and I'm not sure we will be able to discuss everything you can see here, but what is important is to have clear what is the purpose. The purpose is to give you a better understanding of the science behind climate, our knowledge related to climate, and therefore to climate change. Why this is important? It is important because we recognize the key role of climate in some branches of engineering, economics, politics, because climate means an expression of nature. Climate is a driver of our interaction with nature, and therefore climate is the driver of our relationship between the humans and the environment, which requires some strategy, some adaptation, requires some intervention, because as you know, the natural environment is by definition not easy. In some of the cases is hostile. It presents risks, it presents hazards, and therefore humans, in order to manage this relationship with the climate by at the same time preserving the environment, humans need some strategy, some intervention. It's clear that where we have a good relationship with the environment is because we realized structures. We built infrastructures to manage this relationship, which is intrinsically not easy. And therefore, getting a knowledge of climate is important. Why it is important? First of all, to predict it. We need to be able to predict what can be the impact of climate on humans. And therefore, in order to make predictions, we need to understand the underlying mechanisms. Of course, we can also base predictions on experience, like we know what happened in the past, we know what can be the problem, and therefore we make a prediction basing on a kind of expert knowledge, even without knowing the science. But in some cases, and especially in the presence of change, experience is not enough. In order to make predictions, we need to know the underlying mechanisms, the underlying physics, the underlying chemistry, the underlying theory of economy and of political sciences. And this is why we need also to look at the science, because knowing a mechanism means knowing the science behind it. And this is why we try to gain a better understanding of how the climate system works, how the climate system is changing. And this better understanding allows us to make predictions and to estimate uncertainty of these predictions, because uncertainty of these predictions is something that is necessary in order to devise solutions. So we don't have to neglect uncertainty. We have to deal with it, because uncertainty, in principle, cannot be neglected. It is there. Anything that is related to environment is characterized by uncertainty. Anything that is related to human behavior is characterized by uncertainty. So it's something that cannot be eliminated, cannot be then neglected. If we neglect it, we neglect something that exists. So we need to simply manage it. But in order to manage it, we need to know uncertainty. And to know uncertainty, science is extremely important, especially in the presence of change. When we talk about science, you have to take into account that we don't know everything related to the environment and related also to climate. But we don't know everything also related to many other topics. Science exists precisely because we have open questions. And the open questions mean lack of understanding. So don't assume that we know everything. We will talk about science, and we will talk about missing knowledge. We will talk about gaps in our knowledge. And this is extremely important to recognize it, especially because today, the media and in general, the attitude of people tends to assume that everything is known, everything is predictable. And also when we see discussions about what the future will be, but uncertainty is very rarely mentioned. Because, as I said, it's also an attitude. It's also a natural reaction of the humans in front of disasters. Everybody wants to identify a cause. Everybody wants to identify a guilty strategy, a guilty person, a guilty institution, by assuming that if there is some missing information, missing capability to predict, the assumption is that there must be a guilty reason for it. In some of the cases, the reason why we miss a prediction is simply the fact that there is lack of knowledge, and therefore our reaction shouldn't be to identify a guilty institution, person, guilty strategy, but rather to understand what is missing, to improve science and or improve our capability to estimate uncertainty. So this is why we look at the science of climate. So first of all, let me introduce the problem. Let me provide an introduction to this course by clicking on the first link. I go back. I clicked on introduction. And here you see a lecture that is given in the form of a presentation. Is not a web page. This first link is not a web page, is not a PowerPoint, is a presentation that I can put full screen. And then I will use this presentation to give you a first glance of what is climate, what we are studying today, and what we are studying together in the coming months. So first of all, let's introduce some considerations. And I use these two graphs that are taken from this website, Our World in Data. Let's just click on it. I mean, what I am showing to you on the screen is available online to all of you. So if you want to follow me directly on the presentation rather than on the shared screen, this is also possible. So let's click on this link for Our World in Data. And here you get the web page of Our World in Data with the same graph that is reported in my presentation. This is updated actually because this graph is continuously updated. And in fact, the last point is, you see, it's already included. Its last point is December 15, 2024. So it's more recent with respect to my graph. And you can see here a progress of global warming. It's a graph depicting monthly temperature anomaly. So monthly temperature averaged over the Earth during time. Anomaly means, and there is written here, means deviation from the 1951-1980 mean. So if you start from the beginning of the observation period is 1880, you see that we are below average. And then there is an increase. The increase is not steady. There is a peak around 1940s and 1950. And then we had a decrease. This decrease here was something concerning because keep in mind that usually lower temperature are associated with an increase of extreme events, in particular floods. In the history, you can constantly see an association between periods with lower temperature and flood occurrence, extreme rainfall occurrence. So during this period around 1940, 1950, up to you see here, up to end of the 50s, there was a decrease of global temperature, which also lasted until, you see here, until the 1980, more or less. This period of lower than usual, where usual I mean the previous 2 decades, 1930, 1940s, this period of lower temperature, lower than usual, triggered a lot of concern globally, and the concern was related to the occurrence of the so-called global cooling. So let's open another web page here, and let's look for global cooling. Okay, just one second. Let's see English. I don't want to sign in, so let me sign in. Okay, just one second. There is a Wikipedia page. I want to skip this. Okay, sorry. Here it is. Global cooling. Sorry, I had a little bit of delay because I couldn't manage. I'm not on my PC, so be patient. Global cooling was a conjecture, especially during the 70s, sorry, of imminent cooling of the Earth, culminating in a period of extensive glaciation. This concern lasted up to, as I said, end of the 70s, and was really a serious concern. But then, and I'm closing this page here, then you can see that the temperature, starting from about 1980, started to increase. And this increase was particularly evident starting from the end of the 80s, beginning of the 90s of the previous century. Starting from about 1990, the increase of temperature was quite constant, with the exception of a period from 2004, 2015, and 2012, 13. During this period, the temperature was steady. If you make a zoom here, the nice thing of these graphs is that you can zoom. So let's put the zoom, okay, and let me just, okay. Now we are zooming from 2016 to 2022. And you see here, if you look at this zoom here, it's quite constant, the temperature. There was some warm period, but then a cold period. So this is another period that was 6 years long with no increase of temperature. But then, if you look at the recent time, let me just change the zoom from here. You see, from 2022 to today, there has been a significant increase. Keep in mind that these are monthly data. So if you average over the year, then you would find that indeed the increase is quite steady from 2022 to 2024. Actually, 2024, you may have heard, is the first year on record where we passed the threshold of plus 1.5 degrees centigrade with respect to the pre-industrial period. So indeed, 2024 was the hottest year on record, and the first that was past this threshold, which is a symbolic threshold. So the global warming we are talking about is in the range with respect to the pre-industrial period, is in the range 1.3, 1.5 higher. Why I say 1.3, 1.5? Because usually when we measure the rise in temperature with respect to the pre-industrial period, we need to average over a sufficient number of years. So only 1 year, 2024, with temperature higher than the threshold plus 1.5 doesn't mean, if we average over a number of years, still it's below plus 1.5. So it doesn't mean that we are definitely above 1.5. It may be that 2025 is lower than plus 1.5, because as you see, there are some fluctuations. By the way, this website, Our World in Data, these are open data, is extremely interesting for many different types of information. If you look at resources, data catalog, you have a lot of data here related to these categories. For instance, poverty and economic development, 4,000 charts. This is, for instance, the first one is gross domestic product per capita 2023. It's a kind of information that is available. Food and agriculture is another category. Energy and environment, population and demographic change, health, violence and war, human rights and democracy. So you see a chart on maternal mortality ratio, democracy index, which is an index that aims to quantify the level of democracy in a country, share of deaths that are registered, living languages, living conditions, community and well-being, innovation and technological change, education and knowledge. So you see a lot of charts, thousands, literally tens of thousands of charts. So it is an extremely interesting website, by the way. So this is the picture of global warming, as you see, which is something that is indeed concerning, because if you think at the fact that this is a global average, if you think at the fact that there are locations where the increase has been lower than that, but locations where the increase has been higher than that. And typically in mountain regions, in cold regions, the increase of temperature has been higher than the global average. Over the Alps, for instance, we are already experiencing average temperature that is above +2 degrees with respect to the pre-industrial level. And therefore, you know, it is a change that is indeed important. Of course, it is bringing something related, some related changes that are have an implication on our society. The implication may be also positive. I'm not questioning that. Positive means that, of course, in a warm climate, we enjoy some benefits. And if, for instance, if I say again, if we look at the history, it is during the cold times that we experienced the highest flood frequencies. In warmer periods, usually, the relationship between humans and the environment is easier. Let's look now on the right, and on the right you see graph of global freshwater use over the long run. Let me just look at the link in our World in Data. It is something impressive. I mean, you see that we start in 1900 around, this is expressed in cubic meters per year, and or you may say, you may express it in billions of cubic meters per year. We start from 600 and just 1 second, is, yeah, 600 billions of cubic meters. And then you see that after the Second World War, around 1960, the increase in freshwater use is impressive. And we got to a level that is above close to 4 trillions. So there has been an increase that is really like almost 10 times. It's really impressive. So it's clear that a question arises here. Are these increases related in some way? If you look at the previous graph, at the two graphs, and you see that indeed we may see some relationship. Of course, it can be a spurious correlation, but the correlation is clear. And so, indeed, we coined recently a term, great acceleration. Let's see this link. The great acceleration in Wikipedia is defined as the dramatic, continuous, and roughly simultaneous surge across a large range of measures of human activity. And one measure is the use of water. But of course, we see that there are several measures that increased simultaneously, and also there is a simultaneous increase of temperature. So it's clear that one suspects a clear relationship between the human activity and temperature, the increase of human activities and the increase of temperature. Especially because also we see similar increase in the emissions of CO2, of carbon dioxide, because of the burning of fossil fuels, because of the increase of several human activities related to CO2 emissions. And therefore, it was quite clear to suspect a direct relationship between human activities, increase of CO2 emissions, and increase of temperature. Okay, this is quite clear, quite obvious. Okay, let's go back to our presentation. And let's close this. Just 1 second, I want to, okay, here we are. So just remember this term, great acceleration. There is also correspondence between great acceleration and, as we see, human population, as we will see. So another question here comes forward. So is it unavoidable? So is it unavoidable that if we increase the number of humans, we have an increase of temperature? We will see the increase of global population is dramatic, has been dramatic during the past century, and still is dramatic. So it's clear that here there are some questions that come forward, interesting questions. So let me start now with some definition, and I also want to stimulate an interaction with you, as I said. So here, the next slide, what you see on the screen now, is presented in the form of a question related to the definition of climate change. So what is climate change? And here you can select the most appropriate answer according to your understanding. So what is climate change? And these are the 4 possible questions. This could be like a question in your quiz for the exam. Is it a global increase of temperature? Is climate change a global deterioration of climate? Is climate change the occurrence of unprecedented extreme events? Is climate change a long-term shift in weather patterns? So what is climate change? And then there is a second second game, sorry, here. Place the missing word to complete the definition of weather and climate, because the purpose of this slide is to learn the definition of what is climate, what is weather. You have to place the words in the missing boxes, in the boxes of the missing words. And you have to place into these white boxes the word climate, 1 occurrence, and weather, 2 occurrences. So use the capital letter for the first letter of each paragraph, okay, of course, because to allow automatic recognition. So you see something missing refers to the day-to-day state of the atmosphere, such as the combination of temperature, humidity, rainfall, wind, and other factors. Something missing describes something missing of a place averaged over a period of time, often 30 years. So it would be interesting to know what is your choice of the first question and the second question. So I would say here, keeping into account that we have to include, to put there 3 words, weather twice and climate 1. So I would put here weather, refers to the day-to-day climate here. Describe the weather, because this is the only one missing. Okay, good. And here, several people would say climate change is a global increase of temperature. Okay. Now, you see here that I was wrong, and indeed, climate change is a long-term shift in weather patterns, and now it's correct. Good. Now, let's try to check here below. Perfect. This is correct. And look what is written in blue. Think about it this way. Climate is something that can be expected to happen in general, like a cold winter season. Whereas weather is what a person might experience in any given day or any given hour, like a snowstorm in January or a sunny day in July. So what is climate? Climate describes the weather of a place, or you may say the weather of the world, averaged over a period of time, often at least 30 years. So this is why I mentioned to you that global warming is measured by averaging, not only over a single month or a single year. We need to average if we want to talk about climate. And climate scientists precisely say the length of the average should be 30 years at least. So climate is the average of weather. Then what is weather? Weather refers to the day-to-day state of the atmosphere. So if today it is a cold day and I say today the climate is cold, this is a mistake. Today the weather is cold. Climate, when I talk about climate, I should average over 30 years. Actually, you can also think of climate like an average over 10 years if you specify it, but still has to be quite long, cannot be climate in 1 year, okay? 10 years is good. Once in a scientific paper, I tried to estimate climate change by averaging over 10 years of data. And one reviewer said, no, please, make it longer, 30 years. But okay, 10 years, 30 years is still climate. But keep in mind, climate is not for 1 day, climate is not for 1 year. So if I say that 2024 was the warmest year on record, I cannot say that it is representative of climate. So I cannot say that climate is plus 1.5 warmer than the pre-industrial level. I need to average over some years. I hope everything is clear. If something is missing, you don't understand, please let me know, okay? So now you know what is climate, what is weather. Keep in mind that you will get this question in your quiz, not for sure, because questions are randomly chosen, but this is something strong. If you don't have the definition of climate, you don't have the definition of weather, you understand that you cannot talk about climate change. It's impossible. You cannot say that you know the science of climate change. Definitions in science, in theory in general, are extremely important, okay? And they are especially important when you talk with people in communication. You have to stick on definitions because otherwise you are not understood. Or let's say otherwise you are misunderstood, which is even worse than not being understood, okay? So what is change then? We define climate. What is change? So climate, keep in mind that naturally is not constant. So sometimes you listen to people saying climate is not stable anymore. Climate has never been stable. I mean, climate is varying naturally. It is naturally variable and naturally trendy. Trendy means that in nature, climate is affected by trends. You have seen the global temperature. There is a period of warming and then a period of cooling and then another period of warming. However, it's important to distinguish variability and change, okay? So let's look at these two graphs, which are alternating in an animated graph, actually. And this is the temperature change in the same scale. In the vertical axis, you have the same scale and the same period. In the horizontal axis, you have the same period. in a temperature change, annual temperature actually, in tropical America and Northern America. You see that indeed there is warming, it's clear. It's warming, but on the other hand, with a very different pattern. So it's easy to see the warming in tropical America, the red graph. It's not as easy to see the warming in the Northern America because in tropical America, the data are condensed in a small range. In Northern America, the data are spread over a larger range. So this means that the temperature, the annual temperature in Northern America is affected by more variability than Central America. This is quite obvious, than Tropical America, sorry. This is quite obvious. I mean, we can clearly see less variability. So what is variability? Variability, it is how spread out or closely clustered a set of data is. So if the data are spread over a wide range, the data are more affected by more variability. If the data are condensed, clustered in a small range, we have lower variability. Change is defined as a long-term shift in patterns. So variability means that you may have local situations, local increases, but in the long term, the situation is stable. This is variability. So you may have local patterns, but in the long term, you don't see a clear change. So it means that the data have variability. Change, instead, is a shift in the long term. Basing on the definition and basing on the graph, you may recognize that in some of the cases, maybe not easy to distinguish the effect of variability from change. And this is actually one of the most active debates in climate science. So is the warming in the past 30 years the expression of a change or the expression of variability? Of course, we have a lot of reasons to conclude that it is an effect of change, but still the discussion is very active. Okay. Of course, understanding variability and change is extremely important to make a difference. We need to make a difference between variability and change, because we need to make a difference between local patterns, a local increase, and an increase that is going to last in the long term. And because we need different solutions. You understand clearly that if the current global warming was something that is expected to decline starting from 2050, the solutions, the concerns, and the corresponding solutions would be completely different with respect to our current predictions that say that global warming will continue if we don't mitigate climate change. So it is extremely important to understand when an effect is given by variability and when an effect is given by change. You may say, what's the problem here? If I get adapted to climate change, if I find a solution to the current situation, which is a warming situation, what is the problem? The solution is good anyway. I mean, at least for the period when global warming is continuing. On the other hand, keep in mind that global resources for fighting against climate change, global resources for improving our relationship with the environment are reduced. We cannot get protected against everything. We need to set priorities for an efficient use of resources. Keep in mind that if we decide to adopt a solution against climate change, whatever solution is, it is a solution requiring a lot of costs, and these costs are paid by the citizens. There are no hidden treasures that we can use in order to cope with demands for resources without impacting the population, without impacting the individuals. And keep in mind that this impact is higher for individuals with less resources. So, I mean, we have indeed the duty of identifying priorities, identifying the best solution. And this means that we have to recognize change, we have to recognize variability. In most of the cases, this means that we need to get supported by science, because distinguishing between variability and change is not easy. And this is why we need science. Okay, let me look at the timing, because I still have 5 minutes to go. So, indeed, climate change, we know that is one of the major concerns of modern society. Keep in mind that usually when we poll people, and we ask people the explicit demand, the explicit question, what is your main concern for the future? Climate change is usually not ranked first. It is ranked actually quite low, and it may be the sixth. In Europe, it is in the last poll that I visited, it was listed as the sixth concern. The first concern was geopolitical tensions, geopolitical problems, and so the risk of a war. And also terrorism is ranked very high, and personal safety is ranked very high. So usually climate change is not one of the major concerns for people, but overall, over society, in science is a great concern. Overall is one of the major concerns. And indeed, one of the reasons why it should be indeed be a major concern is that, solutions need to be carefully devised, because it takes time to resolve the problem created by climate change. And I think it is relatively easier, at least in terms of time, to resolve the other concerns that I mentioned. Climate, it really takes time, so we need to act early. So another question is a topical question, which I don't want to address in this course, because I think it is beyond our scope, our purpose. Is the responsibility for climate change? So is it human-induced or not? And you may say that this is a stupid question, because we all know that climate change is human-induced. But actually, once again, if you look at the polls to people, still there is a significant percentage of people, in the United States is about 30% of the population, thinking that climate change is not necessarily due to humans. Of course, it much depends on the way the question is formulated. So this poll that I mentioned was formulated in this way. Do you think the first humans are the main responsible for climate change? Usually people don't exclude an influence of humans, but many people also think that variability could be the reason, could be the explanation for climate change, an internal variability of climate. So, I mean, the question looks stupid, but actually is not so stupid. So here I formulated it in a less challenging way. Why do you think that humans are responsible for climate change? And this already contains an implicit assumption that humans are responsible. So this question should be addressed to those people who indeed believe that humans are responsible. So why do you think that humans are responsible? Select the most reasonable answer. Climate models cannot explain current climate change unless anthropogenic forcing is considered. The media agree on the anthropogenic forcing of climate change. Scientific community agrees that anthropogenic forcing is dominant, and global warming is occurring with unprecedented speed. So, I believe that if we go by exclusion, we can exclude the media. Of course, it cannot be the media deciding why the humans are responsible for climate change or deciding that humans are responsible. Actually, it could be the scientific community, the agreement in the scientific community. It could be that global warming is occurring with unprecedented speed. Of course, if you look at the comparison between the progress of global population and global warming, as I said before, you see a clear relationship. So it could be indeed the speed, the pace of global warming could be an explanation that brings us, a reason that brings us to conclude that humans are responsible. Also, this explanation is very scientific, but could be a possibility. So what would be your preference? So scientific community, it's wrong. Okay, the correct answer is climate models cannot explain current climate change. So I think this is indeed significant. Let me just go back. I cannot go back to the previous question, but in any case, I can comment. So the most compelling evidence, this is my comment, of anthropogenic influence on climate is provided by climate models, which reflect our current understanding of climate processes. Keep in mind, I think it is extremely interesting, this conclusion. So the reason why we can say that humans are responsible for climate change are climate models. So basically, these models summarize our understanding. These models cannot reproduce global warming unless we put into them a lot of CO2 emissions. It is reasonable. I mean, providing a scientific interpretation through a model is fine. But like any modelers know, like any engineers knows, I mean, modeling is affected by uncertainty. Always, whatever model. And why don't we discuss uncertainty? Because if we want to provide a scientific interpretation through a model, this is perfectly fine, but we also have to discuss about uncertainty, because we need to know how much reliable is the scientific interpretation. But for some reason, as I mentioned earlier, when we talk about climate, uncertainty is something that is not properly recognized, or it's not properly discussed. And you may wonder, why is that? It is clear the reason, and the reason, I think, it is motivated. The reason is that this is a general question related to science, and not only related to climate. Is recognizing uncertainty undermining the trust of public and politicians in science? So if we say yes, it is, then you can understand why, when we talk about important issues, not only climate, important issues for which you need to convince the public, then you can understand why in these cases uncertainty is neglected. Because there is the feeling that it may undermine the trust of the recipients of the communication, of the message. In this case, the public has to cooperate to mitigate climate change, has to put money on it through taxes like carbon taxation, etc. And therefore, the message must be clear. if we deliver a message and say, yeah, but we are not sure actually, it is a message that is not powerful. So this is the reason why I think, it's my interpretation, this is the reason why probably uncertainty is not mentioned in climate science. And you can find also documentation on the web about this interpretation. And on the other hand, you know, neglecting uncertainty has another problem. And the other problem is that if we don't recognize uncertainty in the long term as well, we undermine the trust of the public in science. Because if a prediction turns out to be wrong, in whatever prediction you make, in whatever problem you deal with, if a prediction turns out to be wrong and you didn't specify uncertainty, then the trust of the public goes down. And the next time people will not believe to you. This is why when we see a meteorological prediction, the prediction is often associated with uncertainty. Something like tomorrow it will rain with 10 centimeters of rain plus minus 50%. Because for the very reason that the forecaster wants to make clear that there is uncertainty, at what level they are uncertain, because they don't want to undermine the trust of public in science. So what is the solution? Should I communicate uncertainty in climate prediction or not? You understand that this is a topical discussion. You understand that this is extremely relevant, extremely important, and there are reasons for both answers, yes, no, and probably the best answer is, according to my interpretation, yes, but with a clear message. So about the meaning of uncertainty cannot be something like, yes, but we are not sure. This is not clear. If we, like the meteorological predictions, if we say, yes, plus minus a confidence band, plus minus a range, it's a clearer message. And for this, we need an agreement, a strategy in communication, and we need, of course, a reliable quantification of uncertainty. Because another problem when we talk about uncertainty is that in some cases we cannot estimate it, we cannot assess it, we cannot provide an estimate. And this is why some people prefer not to talk about uncertainty, because it's not a good message to say, I'm not sure, and I cannot really say to what extent I am sure. So you understand the importance of uncertainty assessment. Let's make a second break. The second break up to 1 second to 50 minutes, 3:35, sorry. Okay. As before, I am turning micro and webcam off. Thank you. Okay, here I am. Just to clarify, I will teach up to 4 sharp. So we have 25 minutes to go. Let me go back here. So now that we understand what is change and what is climate, what is weather, let's see some numbers about climate change. So first of all, global temperature meant as a long-term average has raised about 1.3 degrees since 1880. We already discussed this before. Temperature increased more in the northern hemisphere. Keep this in mind. We don't know the reason why the increase has been higher in the northern hemisphere. In the northern hemisphere, there is a higher density of land. There is also a higher density of monitoring stations of temperature. So the reason might be related to the density of the thermometers. The sea level rise from 1880 to 2020 is about 21 centimeter of global average. This is another important order of magnitude. First of all, keep in mind that orders of magnitude when you talk about change are extremely important. So you have to be very precise when you communicate with the public in order not to lose the trust of the public in science. You have to be very rigorous. So the orders of magnitude for this reason are an essential piece of communication. So if you communicate about sea level rise, you have to be aware that we are talking about from the pre-industrial level about 20 centimeters. Global average. Global average because the sea level is not constant everywhere. The sea level, of course, is varying depending on the fluctuations of the tide, depending also on the force of gravity of the Earth. There are changes depending on wind. This is probably the most important reason for changes. In fact, we talk about topography of the ocean, meaning a map of the altitude of the ocean. So if we talk about sea level rise, we have to be very clear in specifying where the sea level rise was measured. The global average is about 21 centimeters. Global CO2 emissions, this is an important, indeed, number, have raised from about 5 to about 35 billions of metric tons from 1940 to 2020. So we have had an increase by a factor of 7. Global CO2 emissions per capita increased from 2 tons in 1940 to about 4.5 in 2020. We have an increase by a factor of 2. Why this difference in the global amount and the amount per capita? Because we had also an increase in global population. Look at the red text on the left. Global population is increased from about 2.5 billions in 1950 to about 8 billions today. This is another important number. So from 1950 to today, in the past 70 years, the global population increased 3 times. So if we look at the global CO2 emissions and CO2 emissions per capita, of course, the increase is larger in the global amount. Global economic losses from weather catastrophes are about 300 billions of US dollars per year, steadily increasing. And here I wrote 2023 was the hottest year on record. Actually, you know now that 2024 again broke the unfortunately not good record of the hottest year. So now we have to substitute 2023 with 2024. And here there is a link to a video from NASA that explains You see the advertisement explains. Sorry. You see explained the progress of global temperature. And this video is interesting because you see that the global increase of temperature is not homogeneous. And you see that there are hotspots. And these hotspots are a little bit fluctuating, but you can recognize clear patterns, and you can recognize the hotspots in the cold regions. And here you see, this is summer temperature. You see that 2023 was indeed the hottest year. So these numbers are indeed important to know because they give you a perception of the problem. Okay. Now, negative impacts of climate change. The first negative impact is global warming. Here I report a quote from National Geographic. Earth is warming up and humans are at least partially to blame. I think it is interesting, this quote, precisely for the wording here. National Geographic is, of course, a trusted reference, at least partially to blame. So there is a recognition in this statement that there is some uncertainty. The causes, effects, and the complexities of global warming are important to understand so that we can fight for the health of our planet, of course. This is what we are discussing today. Global warming impacts the environment, changes the seasonality of several natural processes, and has potentially negative impacts on the global health. Global warming is not uniform. For example, the Alps are warming up with a faster rate with respect to the global one. Global warming impacts on the agricultural practices, water resources dynamics, and management. If you look at the graph, you see that the pace of global warming is fluctuating, meaning that, as I said before, there are different trends, different slope of the trend if you look at a reduced time span. If you look at the local level, you find a different pace of global warming. In the long term, it's clear that there is a global warming. Okay, so global warming is one impact, and then weather extremes. So there is a clear evidence now, based on data, and here we don't, let's start from models first, not from data, but from models like here. Climate models show that weather extremes may be exacerbated by global warming. This is what climate models say. In particular, very intense precipitation and period of low precipitation seem to be exacerbated in terms of frequency and intensity, according to models. It's not clear from models the effect on the memory of these processes and therefore the impact on long-term cycles. Why I put this sentence? Because we know that floods and droughts come in clusters typically, so that we talk about flood-rich periods and drought-rich periods. Cluster means that the system has a memory. So once that we get into a flood-rich period, the system keeps the same state for a while. Global models so far do not reproduce well these memory effects. And this is why I put the sentence, it's not clear the effect on the memory. Now, let's talk about data. Observation of extremes are rare, and therefore it's not easy to confirm with data what models predict. But several studies confirm slight increase of extreme precipitation. there are already available in the literature several analyses of rainfall extremes which show that indeed there is an increase of frequency and intensity of extreme rainfall, especially rainfall with short duration. Keep in mind that when we talk about rainfall, usually we have to specify the location we are referring to and the duration of the rainfall. So if we talk about annual rainfall, is different with respect to daily rainfall because it's different the duration over which I measure rainfall. So what the data tell us is that extreme rainfall with short duration looks increased. What do I mean with short duration? Sub-daily. So rainfall with sub-daily duration looks increased. On the other hand, rainfall with longer durations seems to be unaffected. This is what, again, the data say. And it is in contrast with the prediction of models that indeed show an increase of extreme rainfall, extreme upper extreme, in over the whole set of durations. Indeed, what we observe is limited to short-term rainfall. Okay, let's move forward. Now, floods and droughts. Floods and droughts are caused by extreme rainfall. Floods by high rainfall, of course, and droughts by low rainfall. There are some differences on the impact of climate change in floods and droughts. So while floods are developing over a small spatial scale and also a variety of temporal scales, so there are some floods that last for a few minutes only. There are floods lasting for 1 week. The droughts have different scales, are more extended in space and time. So, I mean, the way in which climate change has an impact of them is very different because different are the scales and different is the type of extreme, high extreme, low extreme. Now, floods and droughts have a significant impact on ecosystems, human communities, and may have health implications. I mean, they induce indeed an high risk. Climate models once again predict an increase of the severity of floods and droughts. On the other hand, the data tells us that, as I mentioned before, only rainfall of short duration is changed. And the data do not provide a clear picture on the increase of the number of droughts and their severity. We had several droughts also in the far past when global warming was much less important, much less significant. So let's try to derive a conclusion from these two results. So what about floods? The fact that only short-term rainfall has increased means that only floods that affect small catchments are impacted by global warming, according to data. Why? Because any hydrologist knows that the small catchments are flooded after a short rainfall, short duration. The larger catchments are flooded after a longer rainfall. So the Po River in Italy is flooded with a rainfall that has a duration of 1 week. A small catchment, like an urban catchment, is flooded after a rainfall of a couple of minutes. So given that, according to data, only short-term rainfall has increased, extreme rainfall, then it follows that if we look at floods, only the frequency of floods in small catchments has increased. We didn't observe in Italy in the past 30 years an increase of the frequency of floods in large rivers like the Po, the Arno, the Tevere. We observed an increase of the floods in small catchments. Okay, then what about droughts? As I said, the data don't highlight an increase of droughts frequency and severity. There are several studies proving that in the past we had important droughts, and it doesn't look like these droughts are increased in recent times. So here there is a mismatch between models and data. Keep in mind, when you talk about climate change and you provide an evidence for it, you have always to specify if your evidence is gained based on models or based on data. Hurricanes. In short, it's not clear if hurricanes are influenced by climate change or not. And here I put two quotes. One from NASA. Climate models, again, climate models predict hurricanes will likely cause more intense rainfall and have an increased coastal flood risk due to higher storm surge caused by rising seas. Additionally, the global frequency of storms may decrease or remain unchanged, but hurricanes that form are more likely to become intense. From IPCC, globally, there is low confidence in attribution of changes in tropical cyclone activity to human influence. This is due to insufficient observational evidence, lack of physical understanding of the links between anthropogenic drivers of climate and tropical cyclone activity, and the low level of agreement between studies as to the relative importance of natural variability and man-made forcings. So you understand that the picture is still not clear. The knowledge of the impact of climate change on hurricanes is evolving. So there is not clear evidence. Sea level rise, we already mentioned something. So 20 centimeters since 1880 of global average sea level rise. In 2021, global sea level set a new record high, and above the new record high is 97 millimeters, so it means 10 centimeters above the levels of 1993. The rate of global sea level rise is accelerating. It has more than doubled in terms of 1.4 millimeters per year through most of the 20th century to 3.6 millimeters per year from 2006 to 2015. So it is now raising the sea level with an increased pace, with an increasing trend. In many locations along the US coastline, the rate of local sea level rise is greater than the global average due to land processes. Of course, we measure the sea level with respect to the land. High tide flooding is now 300% to more than 900% more frequent than it was 50 years ago. keep in mind that high tide flooding is not only related to the sea level, is also related to the subsidence, is related also to the infrastructures to mitigate the risk of flood. It's also related to the development of the coastal areas. So basically, what is the risk for the human health due to sea level rise? We may have injuries related to coastal flooding. We have stress due to the occurrence of extreme events. And this is a very important risk. There is a risk for the human health deriving from the salination of coastal waters, because this is an important note. Even a very small increase of sea level causes a strong increase in the intrusion of salt water in the underground and an increase in contamination of groundwater, which means that if we take water for drinking from the underground, like it happens in many coastal areas, this water becomes increasingly salted. And this is bringing a lot of risks for the human health. And it is important, it is a risk that has to be taken into account very carefully, because as I said, even a small increase of sea level causes intrusion, an increase of intrusion that is very relevant. And also we have the destruction of coastal ecosystems. Now, there are positive impacts of climate change, and we conclude today with some considerations related to that. Like, for instance, if you look at the map on the left, you see that the agricultural yield is predicted to increase in the northern hemisphere because of the more favorable conditions to agriculture due to global warming. Also, we have possible less mortality for cold waves, a decreased avalanche risk in some regions, and also, you know, the increase in agricultural yield, as I mentioned. Also, keep in mind that carbon dioxide is a fertilizer and therefore also has a contribution on the agricultural yield. Tourism may benefit from a longer season, and shipping commerce may benefit from the possible opening of the Northwest Passage. There is a lot of attention in these days because of the increase of the width of the Northwest Passage. And the North region may benefit from an expansion of agriculture. So you see, there are indeed possible benefits, and these have to be carefully considered. In general, the Earth has been affected by climate change also in ancient times. And climate change means that there are lands that are not favorable for living that become favorable. And on the other hand, there are lands that are favorable for living that become not favorable. And the reaction of humans to these changes has always been through migration. On the other hand, if this happens in a longer time, then there is time for humans to migrate. If climate change happens in a short time frame, then of course this change in the conditions of living originates geopolitical tensions, which may then imply wars. And this is the reason of concern today. I mean, overall, there are also benefits due to climate change. On the other hand, to profit from these benefits, we need people moving. We need rethinking of the international settings, international geopolitical setting, which is, you know, it is something that it's relevant. Okay, I think we can stop here. Let me ask you, I stop sharing, and let me just see. I stop sharing and I stop recording. Good. Do you have any question? Okay, so if you have questions also later on, you can contact me. The best thing is if you contact me through the chat of Teams, because so everybody can see the questions, but feel free to contact me in any way you deem useful. I will make the video available, give me a couple of days time, maybe also earlier than that, but please don't send me emails asking for the video before a couple of days. And then we meet again in presence, room 4.2, School of Engineering, and we meet in presence next week, okay, on Monday. Thank you very much. Bye-bye.